Our fairly long exploration of the image analysis service is now done, and we can move on to spatial analysis. Our conversation about this feature is going to be extremely brief. And the reason for this brevity is that the spatial analysis feature was retired on March 30th, 2025. It has been replaced and effectively subsumed by the video indexer. As of when this video is being recorded in May of 2025, it still is in the AI-102 syllabus. And for that reason, it makes sense for us to discuss it, albeit briefly. Given that, here's what we need to know about the spatial analysis service. This was or is an AI service that analyzes real-time video streams from cameras to understand the spatial relationships between people and their movements within a physical space, hence the name spatial. This allows the service to detect people and to understand their position relative to zones and lines. Use cases include counting people, tracking entries and exits, measuring dwell time, and monitoring social distancing, which used to be quite important in the COVID era. By generating events based on these spatial insights, it allows applications to optimize physical spaces, to improve safety, and for the people monitoring these applications to gain insights into people's behavior in different environments. Now, of course, this has been subsumed by the video indexer, that's the recommended successor. Let's contrast these two. Spatial analysis was somewhat limited to detecting people and vehicles. Video indexer has much broader capabilities for object detection. It can identify over 1,000 different types of objects. Spatial analysis was entirely spatial. It did not process audio or speech at all. Video indexer, on the other hand, also includes comprehensive audio analysis and provides transcription, translation, summarization, and sentiment analysis. Spatial analysis did have some strong points of its own. It natively supported event detection and tracking, particularly on the edge. Because it was designed for edge deployment, it could run on local hardware, for instance, using on-prem cameras or devices, and did not require constant internet connectivity. It could detect events and track people or vehicles in real time. Azure Video Indexer, however, is not quite up to the mark here. It works primarily in the cloud and is optimized for post-processing video content, not for real-time analysis. Azure Video Indexer supports limited event detection and tracking, but not at the edge and not as deeply as spatial analysis. Now you can be sure that Microsoft would not let Video Indexer be so clearly inferior to spatial analysis, and so to compensate for this weakness, we have the fact that spatial analysis does not support Azure Arc deployment, while Video Indexer does. Now, Azure Arc allows services to be extended to hybrid or on-prem environments, not just to the Azure public cloud. Because Video Indexer has easy Azure Arc integration, it can be deployed and managed across hybrid environments more easily than spatial analysis. Spatial analysis ran very well on edge devices, but it lacked these hybrid capabilities. So with spatial analysis, you would get local edge processing, but you would not get full hybrid/cloud orchestration that you can get with Video Indexer. Apart from these nitty-gritty, at a high level, spatial analysis clearly specializes in visual analysis and tracking, while Video Indexer, as its name would suggest, provides a more comprehensive framework for both audio and visual content. That does it for our brief but hopefully insightful and informative discussion of the spatial analysis service. This much ought to be enough for you to answer any questions which come through on it in the certification test. We are done with the image analysis service and with spatial analysis, which means that we can now put a satisfying check mark next to the vision service as a whole. Because we are talking about the video indexer service, let's move on to that in a little more detail coming up next.